Okay, welcome back, everybody. Today we are going to discuss finding solutions using a separation of variables. I've discussed this in Unit 6, so this should be somewhat of a review for you, which is a good thing. So let's go ahead and get started. It says up till now, we've only been able to solve two different types of equations. When you're getting a first derivative is equal to some function in terms of x, or when you're given a second derivative of is equal to some function in terms of x. But what about when that function is, or that function, I suppose, is in terms of x and y? So something like this. The first derivative is equal to 2x divided by y. So when you have an equation with two variables, the first thing that's most important, sometimes you'll see this on a free response, is the separation of variables, probably one of the most important parts. So anything with x's on one side, anything with y's on the other side. Now, this first derivative, we can also rewrite that as dy dx. Okay, that's equivalent to that. Now there, if you recall, I brought up the other form, which would be dy equals 2x divided by y dx. You recall that form that we've discussed in Unit 6. Leibniz, that was his form. And technically, it's not multiplying both sides by delta x. It's just two different forms of the same equation. But if you want to think of it as multiplying, it's not going to be wrong if you think of it that way. But technically, that's not what we're doing. So this little y here is not supposed to be with the x's. So we're going to move that over here, which we are going to be multiplying both sides by y. So you have y dy equals 2x dx. So now that is a separation of variables, and that usually gets you a point if you see it on a free response. Okay, so after you separate the variables, you can take the integral of both sides. And this side, you're going to take the integral of y with respect to y, and this you're going to take the integral of x with respect to dx, or x. So again, for this one, it's just power rule. Let's go ahead and integrate with respect to y. We're going to add to the exponent and divide, okay? And it should be plus c, but if you recall, we only need 1 plus c on one side because the c's combine into 1c. So over here, again, we can keep that 2, that coefficient out in front. So we are adding to the exponent and dividing by our new exponent, and then don't forget the plus c. Okay, so the 2's end up canceling out. We're going to multiply both sides by 2, and you get y squared equals 2x squared plus 2 times a constant is still some constant. And then to solve for y, you take the square root of both sides, and don't forget your plus and your minus. Okay, and that's your answer. Okay, so that's a general solution, because obviously we don't know enough information to find c, but that is finding a general solution using separation of variables. So here's a couple examples of how to separate variables. Again, we would subtract the x squared and move the dx to the other side. This one we would divide by sine x. And again, this is dy over dx. This one right here, let's move the x to the other side. Okay, and then again, separate the dy on one side and the dx on the other. So there's a couple of rewritten with separation of variables. So let's go ahead and try this one. This one has the y, so move the y over here. Again, the opposite of dividing. To undo dividing is multiplying. So let's go ahead and try this one. We're going to write that as the cosine of y dy equals 4x cubed dx. Okay, And then again, once you have the separation of variables, the next step is to integrate both sides. What's the antiderivative of cosine y? Antiderivative of cosine. That is positive sine. Again, we've got our coefficient here. We're going to add to the exponent and divide, and then plus c. Okay, so again, the 4's will cancel, and again, you're trying to solve for y. When it asks you to solve the differential equation, they want you to solve for y. So how do we get rid of sine? Well, that's arc sine. And that is your solution. Okay, so there's two examples, general solutions using separation of variables. So nothing too complicated. Now this is finding a particular solution. And the reason why we can find a particular solution is because they give us an initial condition. Okay, and there's two ways to go about doing this. I'm going to start with the way that most of you have been solving your like when you're integrating, when you're turning velocity into position and that type of thing, you were given an initial condition. So this is how most of you were doing it. The first thing is, change colors here. First thing is to write it in Leibniz notation, which is this notation here. Okay, well, that's also a separation of variables. So we separated the variables. Now what gets some people is the integration of the left side. They're like, well, how do I integrate dy? Well, you're integrating 1 is basically what you're doing. You're integrating 1 dy. You're integrating 1 with respect to y. So what would that be? That would just be y. And on this side, you're integrating x to the 1/3. So integrating x to the 1/3, you're going to add 1, right? 1 to the exponent, which gives you 4/3, and then divide by 4/3, which is the same as multiplying by 3/4. And don't forget your plus c. Now, the initial condition is when x is equal to 1, y is equal to 2. So we can go ahead and we can substitute that information in. 2 equals 3/4 times 1 to the 4/3 power. Now this is something you have to remember how to do without your calculator. This is the cube root of 1 to the 4th power. And again, it's no big deal because that's just a 1. 1 raised to anything is 1. But if this was something other than 1, cube root 4th power. So we end up getting, oops, I'm sorry, I forgot my plus c. So all of this is equal to 1 times 3/4. So c equals 3/4. I'm sorry, 2 equals 3/4 plus c. So what does c equal to? Well, this is 8/4 minus 3/4. So c is 5/4. Now a lot of people stop there because you're like, oh, I solved. No, you solved for c. They want you to find the particular solution. So again, you need to understand what this means. Particular solution. It means whose derivative gives you this, and this point works in that. So that solution is y equals 3/4 x to the 4/3 plus the c value you calculated. This is the solution. This is the particular solution. Whoops. So let's go ahead and plug in 1 into here. If you plug in 1 into here, you end up getting 3/4 plus 5/4, which is 8/4. Do you get the result of 2? This has to work in your solution. So if there's a plus or minus option, you have to see which one is it. Is it plus or is it minus? So something to think about. Now, this is how most of you have been solving these. There is another way I showed you, which is the way that I tend to do it. And that is using your initial condition. So if you go to take this original here and you integrate dy, but you use your initial condition, 2 plus 1 to the x, and I'm just going to change that to x to the 1/3. Oops, that should be, we're going to use our dummy variable t. Okay, that's just our dummy variable, so they're not all x's. Remember when we did that? This is the initial condition. So this is another way to solve, and you can do this with the acceleration, the velocity, from velocity to position. This is the given right here. Okay? And this is the way I tend to do them, but again, it's personal preference. So when I integrate dy, I get y, and over here, when I integrate this, I end up getting t to the 4/3 again, multiplied by 3/4, and I'm evaluating that from 1 to x. That's how it's going to be different. So I'm going to go ahead and I do y equals 2 plus I plug in my x. I get 3/4 x to the 4/3. There's my f of b minus my f of a. 3/4 times 1 to the 4/3. And again, you could keep that 3/4 out in front and multiply it in after, but I'm just going to use that as one whole term here. So there's my f of b minus my f of a. Okay, so I get the same answer, 3/4 x to the 4/3. This is right here a 1, so that's minus 3/4. Okay, so I get 2 minus 3/4. I get 8/4 minus 3/4, which is 5/4. Same answer. Okay, so this is integrating and plugging your c in afterwards, which again, from what I'm seeing, most of you are doing this. This is using the initial condition. What do we call this? The net change theorem, I believe, if you want to look back in your notes. Okay, again, personal preference. This is my preference. I'm not saying one is right. One is right, one is wrong. I'm not saying that. Okay, so again, if you see these on a free response, which it is possible, more so on the A/B test, but I do see it on the BC test, these are the steps that you need to take. Okay, separate the variables, take the antiderivatives of both sides, use the initial condition to find the constant of integration, that's our plus c, solve the equation for y, and then sometimes you have to use that equation to evaluate something. Okay, so all of this, it's nice if they give you one of these, because this is usually worth 4 or 5 points out of 9. I will tell you that solving for y, sometimes the math on solving for y is quite crazy, and it might not be something you want to waste your time doing just for 1 point. Okay, so let's go ahead and look at this one. Given the differential equation, find the particular solution. There's those words again, particular solution, determined by the initial condition. Okay, so again, I'm not sure which method you like better, but I'm going to just stick with mine. If you want to stop the video and go ahead and try it, it's probably a good idea. Okay. So step 1, separate the variables. So that's y dy. Now be careful here. This is x plus 1 dx. Okay. Step 2 is to integrate both sides. And again, you can do that right within step 1. You don't have to rewrite it, but I'm going to rewrite it anyway. Okay, so we're integrating y with respect to y. So that's the power rule. And here we're going to power rule on this one. And plus c. Okay, it says use the initial condition to find the constant of integration. I'm just going to go with this because, again, I guess most of you do it this way anyway. So let's just go ahead and go with this. We'll go with your method. All right, what are we given? We are given when x is equal to 0, y is negative 2. That's what we're going to plug in into here. So negative 2 squared divided by 2 equals 0 squared divided by 2 plus 0 plus c. So that is 2 equals c. Okay, so we found our constant of integration, and we're going to plug it back into step 2. Y squared divided by 2 equals x squared divided by 2 plus x plus 2. Now again, sometimes this requires logarithmic, all your log rules, and it can be kind of hairy to solve for y, and it's only worth 1 point, but this isn't too bad. So we'll go ahead and solve this one. So multiply through by 2, and you get x squared plus 2x plus 4. Take the square root of both sides, you get plus or minus the square root of x squared plus 2x plus 4. Okay, so again, remember that your solution has to work, this has to work in your solution. So we have to see which one, as I was saying before, which one is it, the plus or the minus? So I'm going to go back up here. And when I plug 0 in for my y, I'm sorry, 0 in for my x, do I get the plus or do I get the minus? Plug negative 2 in for my y. Oops, sorry, you can't see that. Negative 2 in for my y, 0 in for my x. This has to work in my solution. So when x is equal to 0, let's see here, we have 0 squared plus 2 times 0. I think it's pretty obvious which one it's going to be, right? Plus or minus the square root of 4. Is it plus or minus the square root of 4 that we want? Well, obviously, we want the negative 2. So our solution is y equals negative square root of x squared plus 2x plus 4. So if you forget your plus or minus here in your work and you just automatically pick plus, if it were to be a plus, you're not going to get credit because they want you to test that point, especially when you take the square root of both sides. It will be plus or minus. You then choose, is it plus or is it minus? So this is the solution. And if you want to check, if you take the derivative of this and you replace this y into here, they will be equal to each other. But you don't have to check for that. And then 5, use this equation to evaluate a value. Well, they didn't ask us that, so we're done. Okay. All right, so let's try another one. Again, if you want to go ahead and stop the video and try it on your own, might be a pretty good idea. So the first thing we're going to do is separate the variables. So I'm going to get the y's on one side. So that's actually 1 over y on this side. And then here, it's going to be x divided by x squared plus 4. Okay. We're going to go ahead and integrate both sides. And again, you can just do this right in here. You can just do the integral. That's like 2 steps in 1, which is completely fine. All right, how do you integrate 1 over y with respect to y? That's the natural log of the absolute value of y. And again, plus c, but we're only going to do it on one side because plus c and a c is still a c. All right, how do we integrate this? Well, this is a rational, right? A rational. We're integrating a rational function. That tends to be u substitution. Let me set my u equal to my denominator here, which is usually the first thing we try. So du equals 2x dx. Here's my x dx right there. Okay, so it's going to be equal to the integral, my x, it's going to be 1 over u. And then what is x dx? Well, x dx is du divided by 2. All right. So the natural log of the absolute value of y is equal to 1/2 times the natural log of our u, x squared plus 4 plus c. And we're going to plug in the initial condition. When x is -3, y is equal to 2. And find our c value. Okay, so the natural log of the absolute value of 2 equals 1/2 the natural log of our x squared plus 4. The natural log of 2 equals 1/2 the natural log of, what is this, 13? Trying to solve for c. How might one solve for c? Well, c is equal to the natural log of 2, the absolute value of 2 is 2, minus 1/2 the natural log of 13. That's our c value. Now we can condense that, and if it's multiple choice, I'm going to tell you that that's not going to be. You'll see this in the multiple choice if you don't see it in free response. So let's go back up to our step 2 right here. Yeah, 2, because we're working on it. So we're going to go back up here, and we're going to take the natural log of the absolute value of y is equal to 1/2 the natural value, or the natural log of the absolute value of x squared plus 4 plus our c value. Okay, so on a free response, you found the particular solution, but you haven't solved it for y. And again, this is something you want to do last, solving all of this for y. Okay, many different ways you can solve for y. It's y in terms of x. All of this work that I'm about to do is only worth 1 point. So again, you might want to do it at the end. First of all, I'm going to take my exponents up here so I can use my log properties. You remember that, and I know how much you love your logarithms. So by using my log properties and condensing the sum and the difference, I get the natural log of x squared plus 4. I don't need the absolute value because that is positive. Raised to the 1/2. That's this one right here. And because this is a plus, I multiply those together. So I'm just going to do it times 2. And because this is a subtraction, I divide by 13 to the 1/2, which is the square root of 13, or however you want to write it. 13 to the 1/2, or the square root of 13. Okay? So we have a natural log equals a natural log. So you could use the equality property. See, natural log equals a natural log. So the equality property means that these two things have to be equal to each other. So the absolute value of y has to be equal to all of this. I'm just going to write it like this. This is the same thing. Right? So if the absolute value of y equals this, then y either equals plus or minus all of that. And again, which one is it? Well, we have to test -3 and 2. If I plug in a -3 in for x, which one's going to give me a +2? Is it going to be the plus or the minus? So 2 square roots of 13. I plug in my -3 squared, so that's going to give me 13 to the 1/2, which again is the square root of 13. So these cancel. I need my result for y to be a +2. So I am going to choose, oops, wrong one. I'm going to choose the positive. So your solution for this is y equals +2 over the square root of 13 times x squared plus 4 to the 1/2. And you can write that as a square root if you prefer. It really doesn't make a difference. Okay, now that one wasn't too bad if you remember your log properties. Sometimes only one side has the natural log, and you have to remember how to change it from log form to exponential form. Quickly, I'll review that. If you have like the natural log of y equals, I don't know, 2 to the x plus 3. I'm just making something up. Then y equals e to the 2x plus 3. And if you remember that, changing from log form to exponential form. This is your base. A log is equal to the exponent, which equals that. So this, again, remembering that property from 10th grade. And if you don't, again, you're just going to lose a point. Not that big of a deal. Okay, one more example. Again, if you want to stop and go ahead and try this one on your own, now would be a good time to do that. Okay, so separation of variables would be 1 over y dy equals 1 over x squared dx. Okay, go ahead and take the integral of both sides. You must do a separation of variables first, otherwise you lose all of points no matter what. It's the first thing that has to be done. Okay, so here we have the natural log of the absolute value of y again. And how do we integrate 1 over x squared? Do you guys remember that? Something whose derivative is 1 over x squared? Well, it's -1 over x. Because the derivative of 1 over x is 1 over x squared. -1 over x squared. So the derivative of -1 over x is +1 over x squared. So try to remember that one, because that one usually will come up on the test. Or if you really want to, you could change this to a negative exponent and do it the long way. But I would just memorize that again and do it in your head. Okay? So the next thing we have to do is find our constant of integration. What are we given? We're given 1, 3. So the absolute value of our y value, -1 divided by our x value, the natural log of 3 equals -1 plus c. So that tells us that c is equal to the natural log. The absolute value of 3 is 3 plus 1. So be careful with this. If you want to keep the absolute value around it or put parentheses around it, you can, because I don't want you adding the 3 and the 1 together. Okay, so we go back up to our integration. The natural log of the absolute value of y equals a negative 1 over x plus your c value. Okay, now we need to solve for y. So notice they're not all natural logs, so we cannot combine all of these. We need to try to get the y by itself. And this is where that property comes in that I was just telling you about. A log is equal to an exponent. So all of this is your exponent. So the absolute value of y is equal to e to the negative 1 over x plus the natural log of the absolute value of 3 plus 1. That whole thing is your exponent. Okay. All right. So y is equal to plus or minus all of this. Now, again, I'm going to give you a hint for when these are multiple choice. I mean, could you write plus or minus all of this and then test your test point? Absolutely. But I'm going to show you if this is multiple choice, it's not going to look like this. Your exponent, you have to remember some algebra 1 properties. If I take e to the negative 1 divided by x times e to the natural log of 3 times e to the first power, isn't it true? That's an x right there, and it doesn't look like it, so let me fix that. Isn't it true that when the bases are the same, you can add the exponents? So when you're adding the exponents, you can split it up into a product with the same base, something you might have to do to get one of the multiple choice answers. So I'm going to refreshing your memory with, this is the hardest part of this chapter or this unit, is all the log properties that you may have to use. Okay? So, and this should be plus or minus, because it's absolute value. Okay, so we have e to the negative 1 over x, which is just e to the negative 1 over x. What is e to the natural log of 3? Well, again, that's just 3. And what is e to the first? That is also e. So we have 3 times e to the first. This is acceptable, or y equals plus or minus 3 e to the negative 1 over x plus 1. That's acceptable. But again, you have to determine, is it plus or is it minus? Any of these forms are acceptable, but you have to determine plus or minus. So let's go ahead and use our test point, which was what, 1, 3 again. So if we plug that in here, we want to get 3 when we plug in a positive 1. So this is e to the 0. So again, which one is it going to be? It's going to be the positive. So the solution, again, the solution, whichever form you wanted to use, is going to be the positive. And this is what I was saying, that you have to put plus or minus and show you used a test point. You can't just forget about the plus and minus and automatically get the positive answer. You have to show them why you chose the positive, not that you forgot the plus and the minus. So be very careful with that. Okay, so now it says be sure to state the domain of your solution equation. You have to be careful when you're looking at your solution equation. What do you notice here? X cannot equal 0. So again, another thing that might cost you a point. not that big of a deal, but those are the nuances of this unit, is the log properties, simplifying. I mean, you're used to condensing to this, but are you used to splitting this up? Those are the things that might occur when you see some problems in this unit. Not a major deal, but that's the hardest part. Okay. And we are done with those two topics.